Thank you. And I'm happy to have this opportunity to talk to you about one of the most important problem. Now I must add, just next to the pandemic we're all facing. If you're in California, climate change is almost always linked with fires. So let me start with that. If I can go to the next slide, please. Yeah, so this is photo of the image of the sun and the sky I took last week from my backyard. So why is the sky red? Simply because the Valley Fire, which is east of San Diego, it's still remnants of it are still there, and when you burn trees, leaves, and any organic matter, you give off soot. This is technically called black carbon, most of it known as black soot. And this soot is so tiny, they scatter the blue and the green light and the violet away from the sun. So what you see is the remnants, just the red. That it's still about 6:30 in the evening. The sun was about half an hour from setting up, and you can see the red, fiery red sun. Again, it's because between you and the sun are this black carbon soot, which took away the blue and the green light. So let me tell you the connection between climate change, global warming, and fires. So this shows the statistics. It's interestingly, we've already gone beyond that. It says 2.5 million acres. We are close to 3 million acres. It's a record which was set last week for California. And we know similar things happening further north in Oregon and Washington state. How bizarre is this record? It's just in the last 20 years, 25 years, the acres burned has increased by a factor of 2 to 3. So this is actually a picture of the Valley Fire. And I show an equation there, which has a death grip on everything that's happening. What that equation is telling you on the left-hand side is the vapor pressure of water. It increases exponentially with temperature. So this is the rate at which water is evaporating from the soil, from the tree trunks, from the leaves. This evaporation is happening every second of the day, every minute, every hour, every day, every month, every year. The rate at which it's increasing is about 6% per degree of warming. California has already warmed by 1.5 degrees. In principle, then the evaporation has increased by about 10%. Even if the rain falling on our head is the same year to year, the evaporation is increasing. So things are drying out. That's one of the fundamental reasons for the spontaneous combustion of when the fire is lit, it goes to thousands and millions of acres. So that's happening in the West Coast. Our East Coast colleagues would have friends and family on the East Coast would have a similar issue with the same equation. So why are hurricanes getting more intense? Same thing when the atmosphere is warming. Because of more evaporation, the atmosphere holds more moisture. Again, that's gone up by 6 to 10%. And this has been measured worldwide, increase in the moisture. Some places 4, 5%, some places 6, 10%. And this was all theory about 30 years ago. And I was curious, and in the graph on the side you see, a student of mine and I downloaded all the satellite data and plotted the water vapor in the air on the vertical scale and temperature of the ocean on the horizontal scale. And we were shocked to see the actual data showed this monotonic increase in the water in the air, just following that equation, within few percent of that equation. So in spite of all the controversy you see in climate change, we understand why the weather is getting more extreme. It's been now simulated by models. We can understand it theoretically, and it shows by data. So let's ask ourselves the question. The planet has already warmed by about 1 degree Celsius, which is roughly about 1.8 degrees Fahrenheit. We are all used to the Fahrenheit scale. If we don't do much about climate change over the next 10, 15 years, there is a 5 to 10% probability beyond the mid-century, which is just about 30 years away. After that, the planet could look like this. This is basically showing areas of drought. So you see the entire Amazon, the entire Southwest, including California and Oregon, the entire Mediterranean I love to visit, South Africa, Eastern China, etc., etc. So, astronomers think of Earth as in being in a Goldilocks zone, at the right distance from the sun, so our temperature is livable temperatures. But with global warming, our Goldilocks zone is going to shrink, and I'll touch on that later. The key message I want to leave with you today, and that's what we're going to talk about the rest of the talk, it's not too late. There are plenty of solutions we can put into action, but we have a decade to implement these solutions. But enormous investments are needed to accelerate the implementation. That's going to require tremendous public support, and that's where those of you who are listening, you come into this picture as part of the solution. So the first thing I want to mention to you is that climate change science is intensely data-driven. I am emphasizing this because this problem has become so political and so much misinformation. I myself was at NASA from 1974 for about 3 years and helped the engineers design this satellite to look at the heat budget of the Earth. More recently, after I joined Scripps, we developed unmanned aircraft to measure the pollution directly with multiple instruments, with unmanned aircraft, with ships, etc. So where is this climate change problem coming from? Let's talk about, let's say after my talk, you get on the car because you've been trapped at home due to COVID, and you take a ride and come back. Okay, so you would have burned some part of the gasoline in your car. But what happens to it? See, that gasoline is basically hydrocarbon, hydrogen and carbon. So when you burn it to get energy, the carbon gets attached to the oxygen in the air and becomes carbon dioxide. It is one of the most insidious environmental ecosystem damaging gas we can think of, simply for one reason. Once you release it, half of it stays there for 100 years, and about 20% stays there for thousands of years. So why should we worry about it? What it means is that this thing is accumulating. So it is not inconceivable that the carbon dioxide which was released by James Watt, the British engineer, steam engine, 150 years ago, we are still breathing it. It's still there. So how much have we emitted since James Watt's time? 2 followed by 12 zeros, tons, 2 trillion tons. And a famous Scripps scientist, David Keeling, was the first to record this increase. Thanks to him, we now know how much of this 2 trillion is still up in the air. Shockingly, it's almost 1 trillion tons of carbon dioxide is above us, on our head, over our head. So it's covering the planet like a blanket, just like a blanket on a cold winter night traps your body heat and keeps you warm. This blanket of carbon dioxide traps the infrared heat coming from the Earth and the atmosphere and traps it, sends it back, and heats the planet. It's just as simple as that. It is basic quantum mechanics. It is basic molecular physics. There's nothing to escape it. See, until 1975, scientists thought it was mainly carbon dioxide we are releasing, which is heating the planet. In 1975, I was just finished my graduate study PhD. I stumbled on this major discovery that chlorofluorocarbons, these are compounds we used as refrigerants and propellants, the spray cans. I discovered that they are about 10,000 times more potent than CO2 per ton. So that now that whole field of non-CO2 is expanded. There are about 6 different such potent gases we are releasing. So you see, by 1980, it became clear to me we are dealing with a major problem. I didn't think it would become crises like this. And I said, if this theory is right, I need to know when we are going to see this warming and test the theory. So we did a statistical dynamical theory and made a prediction. There was a climate model that if this warming due to CO2 is real, we should see this warming by year 2000. So let me show you next the record. So this shows, planet surface temperature collected over tens of thousands of instruments, and billions of data sets has gone into this to create this history of how the planet's temperature changes. Temperature changes even without us, up and down. So there are some cyclical stuff going on. But when we made this prediction in 1980, the planet was still cooling. And I know many of my colleagues thought I was crazy. And so you can see it was in year 2000 when the warming exceeded what we call the background noise or the natural. So it was a spectacular confirmation of our theoretical understanding of how the planet responds to our pollution. So using the similar set of approach, 2 years ago, I teamed up with two colleagues, one at Texas A&M, another here at UCSD, David Victor, and we made a prediction that the planet's warming, which is about 1 degree as of 2 years ago, will accelerate by 50% to 1.5 degrees in 10 years by 2030. We were again the first to make this prediction, and just last week, the United Nations released a report which sort of supports this. So what does that mean? When you go from 1 to 1.5, that's a 50% amplification. So in principle, if that equation which holds a death grip on this extreme weather would say everything we are experiencing, particularly drought and fires, would enhance in strength by about 50%. So what its implications are, I'll pick it up towards the end. So one thing I want to mention to you is that the skeptics argue, well, our climate is always changing. It's cyclical. What is another 1 degree, 1.5 going to do? The answer to that is first is they are right. Climate changes tremendously. So I'm showing you how the climate has changed over the last 60,000 years. What you see here is it was always colder. You have to go back to 130,000 years before you saw this current warm epoch. So the climate goes from cold to warm, cold to warm. Last 10,000 years, we have been in this warm epoch. It's called Holocene. What we are doing is heating the planet beyond the warm epoch. That's why it makes it unprecedented. If the warming goes to 1.5 degrees, that would be a planet none of us, no Homo sapiens, and no other species on the Earth has witnessed probably in the last million years or more. So we are on a new regime. That's the worry. That's how to answer those who say climate change is cyclical. So enough of the bad news. So let me address how do we solve this problem? And particularly, what is the University of California doing? About 4 years ago, 5 years ago, our president, Janet Napolitano, the UC president, asked me to lead an effort to come up with solutions for climate change. About 50 faculty, just overnight, I just started to send email, 50 joint top experts in all 10 campuses. So we coined our thing, bending the curve. I know bending the curve, flattening the curve is a big terminology now with the COVID. And we came up with 10 solutions to the problem. So, what we did was put our solutions under 5 pillars. That's in the outer rim. The center one tells you what the science says. What should we do to control the warming? And remarkably, they're simple solutions in principle. First is make the planet carbon neutral. Just switch from all carbon emitting sources to renewables. The second is there are many super pollutants. I talked to you about CFCs. And if you bring all these non-CO2 pollutants, they alone can cut the warming by 1 degree, and we have technology to mitigate them. Just give you one example, soot, which comes out of diesel, 1,000 times more potent than carbon dioxide. But we have diesel particulate filters. Many cars now, in fact, most diesel cars in California have to have these filters. Third, Remember, I said we have put 1 trillion tons in the air already. We have to suck some of them out. We call it atmospheric carbon extraction and then energy efficiency. So those are what science tells you what to do. The problem is, how do we do it? We have technologies, but we are not doing it. So that's where this group identified societal transformation as the top solution set we have to do. And that's what I'm going to talk to you about. After that, I had dedicated myself to the societal transformation. Let me share some of my stories with you there. Before I go to the societal transformation, if you ask me, tell me the most important action we need to take, that again is simple. Declare fossil fuel as outdated technology, okay, and switch to abundantly available renewable, solar, wind, geothermal, even nuclear. But we have to be careful. We have to be people-centric. So before we declare fossil fuel outdated, we need to figure out how to provide alternate employment for the millions of fossil fuel workers who made our life pleasant, okay? So it's not abandoning people working in fossil fuels, it is abandoning the fossil fuels. And people say, who's going to pay for it? The air pollution, fossil fuels kills millions, and the lives lost is equivalent to about $5 trillion each year. So we are paying with our lives. All climate scientists are asking is paid with dollars, not with your life. So why have we not taken actions to bend the curve in spite of this overwhelming evidence? Our houses are burning, it's getting flooded, and we are losing soil for drought, etc. Simply because I think, at least in the US, climate change has become political, and we just lack the massive public support needed for drastic actions. So that's what took me to the path I'm on. So the first thing we are proposing is we have to create at least 1 million climate warriors. We have to educate our children and grandchildren who are in schools and colleges. And I find this beautiful saying by Confucius, who talks about, if you're thinking of the long term, educate children. So what we at the University of California have created is an education protocol which had been field tested and can be taken to the whole world. So first is we created a digital textbook. You see that image, Bending the Curve. It's open source. It spends only 2 lectures on science, the rest is all on solutions. And again, written by over 25 top experts in the 10 campus California system. Now some of our authors are on Yale, Cornell, etc. Using this, we created a hybrid in-person course. We've been teaching it last 3 years. Now this course is being taught in all campuses of the UC system. It's being taught in Stockholm University, Taiwan, and then state universities in California. It's basically taped lectures. The students are expected to listen to the lecture and come to the class to discuss solutions. Okay, the learning happens before you step into the class. And then we created that into an online version, and by sheer luck, that online version was released this year during COVID, where in-person classes were not possible. Okay, so we are already COVID ready with this. And then University of California, San Diego has created a MOOC, which is being launched just now. So anyone can take this course. Obviously, you got to start this at the kindergarten level. So I teamed up with the Dean of Education at UCLA and the CSU, several vice chancellors of education, and we have created a new program for teaching K-12 teachers, UC CSU Environment and Climate Literacy Project. We met for 9 months, created a working group, we have created a report, we have created a proposal to get there, and that's being now pursued by UC and CSU to take it to the next stage of really developing a curriculum for K-12 students. I'm hoping in 2 to 3 years, it'll be taught in all the schools in California. So right now, what I'm thinking is, America has got divided into 2 nations not in practice, but in principle. And the 2 sides are not talking to each other. So I have assembled a group, and we are starting a program called Climate Education for All. This is not college level high school education. This is for everyone, including those who have not gone into college, but we are mainly targeting skeptics. Okay. So I'm partnering with religion for this. What I'm asking for is the teaming up between science, policy, and religion. So why do we need religion? This statement we released based on a meeting we organized at the Vatican, and we briefed Pope Francis right after a meeting, and we concluded finding ways to develop a sustainable relationship with our planet requires ultimately also a moral revolution. Religious institutions can and should take the lead on bringing about such a new attitude towards creation. What is the entry point? And I'll tell you why I'm going to the faith-based institutions. Our entry point is to address the ethical and moral issues of climate change or climate disruption and educate the public by taking the message directly through churches and other places of worship. Let me address the ethical issue. There are two things here: intra-generational equity. This is the problem I've been working with for the last 10 years. I see the world, there are two worlds. Okay, I talked about two Americas. Now I'm talking about two worlds. The first world is inhabited by about 1 billion people with seemingly unlimited access to fossil fuels. And they are responsible for more than 50% of the climate pollution. Compare that with the bottom 3 billion. I took a picture of this woman cooking my breakfast. She's in the Himalayas, and I was the guest of her and her husband. So they lack access to any energy. All they're reduced to is burning wood. It comes at the great expense. About 3 million of them die every year from inhalation of the smoke. But when there is severe drought, severe flooding, and you know who's going to go down that cliff first, it's this 3 billion who almost had nothing to do with the global warming. So that's the ethical. The even worse situation is the next one, intergenerational. So this is a thing I created to get people to wake up about this issue. There is a 5 to 10% probability, if you think of that plane as the planet's ecosystem crashing, about 50, 60 years. If I tell you that there is a 1 to 20 chance of that crashing, you won't get on that plane. But we are sending our children and grandchildren. They have no option but to get on that plane. So how did I get into this? 10 years ago, when I turned 60, I was pleasantly surprised. Pope John Paul II invited me and elected me in person to the Pontifical Academy of Sciences. It's an academy. There are about 70 scientists in the world, about third of them are Nobel laureates. And you're selected not because of your religious affiliation, but just because of the science. That made me realize that church could be a power of taking this message to the people directly. So we organized a meeting in 2014. And at the end of each of our meeting, we brief the Pope. And this was about how to build a sustainable planet. So in this meeting, the Pope was too busy, so he met us outside where we were staying in the parking lot. So I had all of 2 minutes. So that's what I call it, a parking lot pitch. This was about 8 months before he released his encyclical. I briefed him on the intragenerational and intergenerational moral ethical issues. In his encyclical, which is called Laudato Si, for our common home, the Pope has just a fantastic phrase. He says, the cry of the earth should be heard with the cry of the poor. It was published in 2015. So we formed this alliance, and the Holy Father had a meeting for mayors and governors. I invited our governor to this, and it was really just a game-changing moment. And so many mayors and governors were educated on the imminence of this. So 2 years ago, we decided we are not able to persuade people that this is a serious problem. So we said we need to focus on the health. And so we had convened the top physicians and healthcare providers, and it was co-sponsored by University of California, San Diego. And we released a book just 3 months ago called Health of People, Health of Planet, and Our Responsibility. And that book, apparently published by Springer Book, holds now a record for book downloads on the environmental category. So I am quite enthused about this because it shows we can now take this message using health. So how am I planning to do this education for all? So our strategy is, our team now of this Education for All team includes the CEO of American Evangelical Network. We have top Catholic leaders, and we also have Jesuit schools like Creighton University in Omaha, and we have from Indiana, Notre Dame, and many religious-based institutions. And what we are thinking is that we would develop brief educational material, 5 to 10 minutes on each segments, and have the preachers, community leaders, talk about this to churchgoers directly. Reach out to them. And why do I think this work? I have now spoken in so many churches, I think close to about 3,000 to 4,000 people that I've reached to. This is in Nebraska, Illinois, Pennsylvania, and few other states like this. And most of them, I just get general public because it's always organized by the Jesuit colleges or churches. For example, in San Diego, I talked to about 200 evangelicals. Basically, what I do for them is unpack climate change from all the issues that divide us. I talk to them, it's scientifically based, it's imminent, we have to take action. And so far it has worked. So that's my game plan for getting more public support for climate change solutions. And again, don't forget, there are abundance of solutions to solve the problem.